Yeah, a lot of times it's short to be trig. So anyway, trigonometry is the study of triangles. If one particular triangle is the right triangle. So we're going to start learning these things, and I don't know if you maybe have seen this a little bit from before in your algebra classes, but trigonometric ratios, the stuff you're going to learn in this chapter, you will use next year in advanced algebra. You will use them extensively in math analysis or pre-calculus. That class is also sometimes called trigonometry, and you use them quite a bit in calculus. So we're laying the foundation here in this chapter for lots of exciting learning for years and years to come. So that's why this is the best one in the whole book. All right? So the first lesson is on the trigonometric ratio. And the way this works is, if you take a right triangle, I turn the heat down in here, you'll be happy to know. And all of this stuff that we're doing is going to be with right triangles. You can do it with triangles that aren't right triangles, but it gets a little bit tricky, so you won't learn how to do that until you get to math analysis. If you have a right triangle, what we're going to do is we're going to pick an angle that's not the right angle. Okay? So let me label this A, B, and C. Okay? So pick an angle, either A or B. A. All right. As soon as you choose angle A, the three sides of this right triangle all have special names. Okay? This one right here, bless you, you know the special name of already. Right. That's the hypotenuse. The one across from the right angle is the hypotenuse, and that's the hypotenuse whether you choose angle A or choose angle B. That always stays the same. Okay? But now these two legs, we're going to distinguish between the two of them by calling this leg right here the opposite side, or the opposite leg. Okay? Because it is across from that angle. Yeah, backless is here. And this leg right here is called the adjacent side. And adjacent is a fancy math word or fancy vocabulary word that means next to, right, so close to. So really when you think of angle A, this side obviously is the opposite side because it's across from that angle. This one obviously is the hypotenuse because it's the one that's across from the right angle. It's the slanty one. And that means the one that's left over is the adjacent side, okay? So what the trig ratios are all about is if I were to take those three sides and make fractions out of them, like divide one by the other, what are some different ways that I could do it? In other words, I'll give you the first one. I could take the opposite side, that's where we're going, divided by the hypotenuse, right? No, I'm just saying, what are some ways you can match them up in fractions? I could go opposite divided by hypotenuse. What? I could also go adjacent over hypotenuse if I wanted to. Okay, what? Hypotenuse. Did I hear somebody say opposite over adjacent?
I said that.
Okay, then I could also take the opposite side if I just was feeling goofy, opposite side, and divide it by the adjacent side. What are some other ways that I could divide those sides? I could switch all of those around. So I could, instead of dividing the opposite by the hypotenuse, I could divide the hypotenuse, the length of the hypotenuse, by the length of the opposite side. Or I could divide the length of the hypotenuse by the adjacent side. Or I could divide the adjacent side by the opposite side. All right? And the reason why anybody cares about this stuff is because, let's say that this angle down here is how many degrees? 30. Okay. Let's say that's 30 degrees right there. If I draw another right triangle that also has a 30-degree angle in it, but maybe it's bigger than this one, what's going to be true about this triangle and my bigger triangle? They're what? I thought I heard it. Yeah, they're similar triangles, right? Because the right angle would be the same and the 30-degree angle would be the same. So what would be true about the ratio of the hypotenuse over the opposite side of this triangle and the hypotenuse over the opposite side of an even bigger triangle? They would be the same, okay? And so once I choose this angle, then all of these ratios become the same, okay? And so what's fun about that is that you can go out into the woods or the real world and, like, say this is a lake. Did you guys pick up on the fact that was a lake? Were you feeling lake there? Okay. Let's say that you were thinking potato, okay? Let's say it's a really big potato, okay? Like possibly 5 stories high, and you want to figure out how tall it is, and you can't measure it, and you try and climb up onto the potato, but you can't like get your feet in there because it's not a big potato, right? So it's all firm and stuff, and so you try and climb up and you fall down. But you really want to know how big, how tall this stinking potato is, okay? Well, instead of climbing up there and measuring it, what you can do is you can pick a point right here, and then you can walk some distance this way. I don't know how far, you can decide what. And if you can measure what this angle is up to the top of that potato, then you can draw a smaller triangle that has that same angle in it, right? And then you can figure out how tall that potato is. So that's what engineers and architects and things like that do all the time. They use sine and cosine and tangent ratios to figure out big distances that they can't measure in the real world by using similar triangles and figuring out in smaller cases, all right? So some of you guys said what these are called already. You've obviously seen these before. Opposite over hypotenuse is called the sine ratio. Adjacent over hypotenuse is called the cosine ratio. Opposite over adjacent is the tangent ratio. And those are the ones you're going to see the most: sine, cosine, and tangent. And then they have friends.
What's their friends' names?
If you flip this over, sine goes with what's called cosecant.
Cosecant?
Uh-huh.
Cosecant do it?
Cosecant, yeah, cosecant do it. Cosine goes with secant.
Next.
Oh, that's bad. And tangent goes with cotangent. Okay? So if you flip those around, that's what you get. And so these are all called co-functions of each other since they're flipped over. Sine and cosecant, cosine and secant, tangent and cotangent. And there's a lot of things that I don't like about the way we do math in this country, starting with the way we count. Why is it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? And then you have this weird 11, 12 numbers in there. And then you go 13, 14, 15, 16, 17, 18, 19. Why isn't it 1 teen, 2 teen, 3 teen, 4 teen, right? 11? Seriously? 12? What is that all about?
12 kind of has
Have you ever thought about that before?
12 kind of has 2 in it.
You have? It doesn't make any sense. 12 sort of has a 2 in there. Why is it just 2 teen? 1 teen, 2 teen, 3 teen, 4 teen, 5 teen, 6 teen. It's 21, 22, 23, 24, right? It's not like 2011 or something, or 11. Okay? So that's dumb. Anyway, one of the other things that I don't like is it seems to me that it would make more sense for sine and cosine to be the same thing but flipped over, secant and cosecant to be the same thing but flipped over, and tangent and cotangent to be the same thing, right? And they're actually called co-functions of each other, even though it's a, you know, whatever. So you just have to remember that. You just have to remember what? Oh, I just said something. Okay, you just have to remember the way these go. And there are a couple of different ways to do that. I just go with the straight up SOHCAHTOA. Yeah. SOHCAHTOA, your old friend SOHCAHTOA. It sounds like the name of a summer camp. When I was a kid, true story, I went to Camp Icogwin. Maybe my kids will go to Camp SOHCAHTOA sometime. Okay? And you know that SOHCAHTOA stands for, the S is for sine, the O is for opposite, the H is for hypotenuse. So you remember that sine is opposite over hypotenuse. The C stands for cosine, which we abbreviate COS, but you don't say cos. You say cosine still, even though it's abbreviated. The A is adjacent, and the H is once again the hypotenuse. The T stands for tangent, which we abbreviate tan, but you say tangent. O is opposite, and A is adjacent. Okay? Another one that I heard to remember this is, and this does not have the S, the C, and the H in there, but you can say, oh heck, another hour of algebra. Oh heck, another hour of algebra. But that doesn't make any sense, because who's disappointed to find out they have another hour of algebra? That's exciting. That'd be like,
Wait,
oh
so what
yay.
was that again?
Oh
So
heck.
you'd rather be another hour of
Oh, heck
algebra
yeah.
than doing something
Oh
else?
heck, another hour of algebra. Okay? And when I coached girls basketball long, long ago in another town from here, we went to a game down in, I think it was at Prairie down by Vancouver, and they were warming up, and the other team had on their shooting shirts, they had nicknames instead of, like their real last names, and one girl had SOHCAHTOA on the back of her shirt. And I was pumped. I was pumped.
Yeah, but what if it doesn't mean the
No,
same
that'd be
thing?
totally creepy.
You'd be like, oh, so I was so
Okay, so if you take your book and you look on page something, there should be a table here in the back that tells you the sine, cosine, and tangent of all of the different angles that you want to know. Okay? Maybe I'm wrong. Maybe they only have that in algebra, but that would be weird. Oh, photo credits, don't need that. No, not in there?
Am I allowed to see my name?
No, it doesn't matter right now. What matters right now is, oh heck, another hour of fun. All right, never mind, it's not in there. Okay, well, good thing you guys all have calculators, because these values are all stored in your calculators. So if you look at your calculators right now, you have on those a button that says SIN, that does not, you don't say that's sin, it's sine. A button that says COS, that's cosine. And a button that says CAN, that is tangent. Okay? And so like I said, the nice thing is, since all of these triangles are similar, for every angle, no matter how big or small the triangle is, the answers are the same. Okay? And so you should test to make sure your calculator is correct. Let's figure out what the sine of, what was it, 30 degrees in our triangle? 30 degrees is. So you go sine 30, and you hit enter, and you should get 0.5. Okay? All right? And so that's really super exciting. And you could have figured that out already by looking at this triangle that we drew. I'm getting a little crazy here, I will admit. But in a 30, 60, 90 triangle, we learned before that the short side is x, right? The hypotenuse is, if the short side is x, the hypotenuse is 2x. And the medium side is x squared root of 3, okay? So the reason why the sine of 30 degrees is 1/2 is because if I go opposite side, which is x, divided by the hypotenuse, which is
2x.
2x. What is x over 2x reduced to? 1/2. And so that's why it's 0.5. Okay? What would the cosine of 30 degrees be? Not on your calculator, looking at my beautiful messy triangle there. What is the cosine? If you look at this little fraction thingy right there, the cosine is the adjacent side divided by the hypotenuse. What's the length of the adjacent side?
X root 3.
X root 3. What's the length of the hypotenuse?
Over 2x.
Okay, x root 3 over 2x. So the x's cancel, right? And you would say the cosine of 30 degrees is the square root of 3 divided by 2. Well, you can check that by going cosine of 30 degrees, and you get some crazy decimal, but that crazy decimal that you get is the same thing as the square root of 3 divided by 2.
Okay, I keep putting sine and I keep getting negative 0.98.
Okay, that's because your calculator is smarter than you. And that's going to be an issue for you. You need to hit the mode button right there.
Yeah.
And you need to make it so that the degree word is highlighted in your calculator. Okay? There's another way to measure angles that we'll talk about next year called radians. But right now we are just going to stay with
It's not smarter
degree.
than me. It's
Right?
just,
All right, so on page 641 there is an example for how you might use this. So it looks to me like you are hiking in the woods. And you see a tree, and you want to know how tall it is. And so you make some measurements, because you are a curious person by nature. And so you walk 36 meters away from the base of the tree. Okay? And then you get out your little thing that those dudes use when they're like surveying on the roads and stuff, you know, that little tripod, and they're looking through, they're measuring angles of elevation. So you happen to be carrying one of those around. And so you set it up right here, and you measure the angle up to the top of the tree to be 31 degrees. How can you figure out the height of the tree using that information? Well, we have this angle right here, right? So like I said at the very beginning, once you choose that angle, all three sides now have special names. What is the tree side called? The opposite. What is the 36 meter side called?
adjacent.
The adjacent. Which of our 6 trigonometric ratios uses the opposite side and the adjacent side? Tangent. Okay, and you could also have gotten that from TOA, opposite and adjacent, over adjacent. So what that means is that the tangent of 31 degrees equals what? Not on your calculators, on my drawing.
3 over 36.
The tree over 36. Okay? So if I want to figure out how tall the tree is, how do I get the tree by itself?
Add another 2.
How do I get rid of the 36?
Divide by 3.
I have to multiply by 36 because it was dividing by 36 and multiplying is the opposite. So those cancel out. And now you can ask your calculator, oh mighty calculator, what is 36 times the tangent of 31 degrees?
How do you do that?
You type 36, tangent, 31.
All you have to do?
All you have to do. And if you do that correctly, you get about 21.6. And so that tree is about 21.6 meters tall. Aren't you happy now, Jocelyn, that you know how tall that tree is, and now we can continue on our hike?
I'll just
It was a good thing that we texted each other before we left, and I said, you bring the surveying tripod, and I'll bring my graphing calculator, just in case we want to do any trig on our hike. Actually, she was the one that texted me, but I want to embarrass her by exposing her as a nerd. Okay?
Does it still work for like, if you got, what if you got like sine?
Okay, so why can't I use sine here? What would I need to know in order to use the sine function? I'd have to know the hypotenuse.
What if you knew the hypotenuse?
Yeah, then you just use that instead. So it depends on what information you know. That tells you what trig ratio to use. So if you know the adjacent side and you're trying to find the opposite side, you use tangent. Okay? If you knew the hypotenuse and you're trying to find the opposite side, then you would use sine, because that uses the opposite and the hypotenuse. Okay? So what you have and what you're trying to find will dictate which trigonometric function you use. And so, for example, let's do this. Let's make another triangle. And let's just say that this is just a random triangle. So it's not a tree or a potato. And you want to figure out the length of the hypotenuse. Okay?
So you do the x over... No.
As soon as you choose this angle, this side is the opposite, and this side is the hypotenuse. Which trigonometric ratio uses the opposite side of the hypotenuse? Sine. So the sine of
X over
20 equals the opposite side, which is
X over
410 over x. And this is very important because this is very different than the last one that we did. If you try and solve this by multiplying the sine of 20 by 410, you will be wrong. Okay? What's that? Right. To get this x off the bottom, I have to multiply both sides by x to start with. Okay? So the x's cancel. So x times the sine of 20 degrees equals 410. Then how do I get the x by itself? Divide by the sine of 20. So the way that you figure out what x is in this case is not by going 410 times the sine of 20. You go 410 divided by the
So you
sine
do
of
like
20.
410 and then divide sine.
410 divide sine 20 degrees. And that should come out to be about 12. It's not 1200, is it?
Yeah.
It
I got
is?
1,198.
Oh,
Yeah.
sorry. Okay, so about 1200. You're right. 1,199 or 1200. Sorry about that. Okay, does that make sense? Yeah?
Kinda. Well, that.
Kinda? Okay. Why don't you practice a little bit of this then on your own? Before I do that. Bless you. Now that you know that this side is 1,199 feet, give me two different ways you could find this side. Pythagorean Theorem always works for right triangles, always a handy thing to have. So I could go this squared minus this squared equals this squared, and then take the square root. What's another way I could find this side? I could use cosine instead. Good, because that's the adjacent side, and now I know the hypotenuse, and so I could go this divided by this and figure it out that way. Okay? So once you get two sides, then you are in good shape.